This is Joseph Oler, Project 1 M2K. We're going to remake this by finding our resistive loads. We're going to do so by starting with the DC equivalent, removing the capacitive load. Assuming some of these conditions are true, we're going to jump down here and say our load is going to be 5,000 ohms. Choose an arbitrary R4 to be 10,000 kilo ohms. R3 is going to be 10 kilo ohms. And then we find gamma, which we'll use later. Page. Now we find the AC equivalent and we want our gain to be 1. We're going to just transform this into an R equivalent and then assign R2 an arbitrary 10,000 kilo ohms. DS equals gamma RL VGS. VGS can be transformed into a function of V sig. Divide over V sig, we have our gain, we want it to be 1. Coming down here, R1 is going to be 6,000, but 6,800 is going to be the closest. Wiring, we have our signal coming into this first resistor. That first resistor is the voltage divider for our V naught, our input signal, to be the same gain as our output signal, and that's what that voltage divider is for. This capacitor separates the DC components. We have power coming in at this top row with these three. The middle one comes from the board itself. You can see it. This one goes to this resistor here, and this resistor is the input of our potentiometer. That's R3. Our potentiometer is going to output whatever the lower end of this potentiometer is here. Adding on to this signal, that's going to go to our CMOS. That's going to go in the gate. And then that gate voltage will then regulate the power coming through. Not power, but on this side we have our 5 volts coming through our resistive load. That resistive load is also going through the drain. The drain is on the left side here. So you can kind of see this black wire is the drain on the left side. And then the source on the right side, we come down where we link up with this bottom of the potentiometer across R4. And then this bottom white cord is our VN, which is -5 volts. Then we ground channel 2 and channel 1 to ground, and then using the other ground. Heck, I don't even need this wire, but the ground of the voltage divider. So now we're going to go to Scopy, prove that it works at 11:30. Here we have 1.7 volts coming in, and then 720 millivolts coming out. And I'm going to attribute that to some internal losses. It's relatively, that's a lot. That's about 60%. Not even. That's 40%, but still. My potentiometer is giving me problems too. Whose wasn't. Signal generator is 3 volts per PM. Frequency of 1 kilohertz. Power supply 5. Let's see, there's channel 1 and channel 2. So getting something out. Thanks for watching.